Now children, our next topic is prime factorization. First, try to understand what it means. When we express a number as a product of its factors, we say that the number has been factorized. Like 36. How can we factorize 36? We can write it as 2 multiplied by 18 or 3 multiplied by 12 or 6 multiplied by 6 or 4 multiplied by 9. Now, this factorization can be done like this also. 36 can be written as 2 multiplied by 18. 18 twos are 36. Now this 18, this can be further factorized. Look how. 2 multiplied by, now 18 can be written as 2 nines are 2 multiplied by 9. It makes 18. Now this number cannot factorized further, but 9 can again we factorize 9. 2 multiplied by 2, we write it as it is. Now the factorization of 9 can be done like this. 3 multiplied by 3. Okay. Look at the second case. 6 multiplied by 6 makes 36. Right. Now 6 can be factorized further. Yes. 2 multiplied by 3. Here again 6. 6 can be factorized like 2 multiplied by 3. So in the same way, 36 can be written as 3 multiplied by 12, as 12 threes are 36. So 3 cannot be factorized. I'll write it as it is. Now 12. 12 can be factorized further as 4 multiplied by 3. Now here 2 threes, they cannot be factorized further. 4 can be factorized further as 2 multiplied by 2. So again I have got the same factorization. 2 multiply 2 multiply 3 multiply 3. In the same way, 36 can be written as 4 multiplied by 9. Now these two numbers again can be factorized further. 2 multiplied by 2 makes 4. 3 multiplied by 3 makes 9. So again in the four of the factorizations, at the last I am getting the same factorization in the form of 2 and 3's, right? Now this 2 and 3 are prime numbers, means such factorization where all the factors are prime numbers, that is called a prime factorization of the number. Understood? What do you mean by prime factorization? Such factorization where all the factors are prime numbers, that is called a prime factorization of the number. Now look at the question number 2 of your exercise 3.5. Here this question we can do either by using factor tree method or by division method, right? So here this question is in your book only. So 60 is further factorized as 6 tens are 60. 6 10. Okay. Now 6, we can further factorize 6 as 2. Here is question mark, you have to find it. The other factor for 6, that will be 3. This question mark is replaced by 3. So 2 threes are 6. Now 10. 10 is not a prime number, so we have to further factorize it as 5. In the table of 5 where 10 comes, it comes at 2. So here question mark will be replaced by 2. Now in B part again, 60 is further factorized as 30. 32s. 32s are 60. So this question mark will be replaced by 2. Now this 30 we have to further factorize it as 10 dash. 10 threes. Now 3 we can't factorize it further. Now 10. 10 can be factorized as 2. 2 5s because we want prime numbers. So now the complete factorization, I must say the complete factorization of 60 is 2 multiply by 5 multiply by 3 multiply by 2. Check your answer by finding the product of these factors. 2 5s are 10, 10 3s are 30, 32s are 60. That means our prime factorization is correct, and here all the factors are prime numbers. Now come to question number 3. Question number 3 is, what factors are not included in the prime factorization of a composite number? Now in the prime factorization, as you can see, here we have done the prime factorization of 60. Okay, so here which factors are not included? 1 and the number itself. So the two factors which are not included in the prime factorization are 1 and the number itself. Now in question number 4 is, write the greatest 4-digit number and express it in terms of its prime factors. Now first you'll write the greatest 4-digit number, that is 9999. Now you have to express this 9999 in the form of its prime factors. So let us see how we can find out the prime factors. I am using here division method. This is division method to find out the prime factors. So I know 9999 will be divisible by 3. So 3 3s are 9, again 3 3s are 9, 3 3s are 9, 3 3s are 9. Here again I can see it can be divided by 3. Again I'll divide it by 3. 3 1s are 3, 3 1s are 3, 3 1s are 3, 3 1s are 3. Now 1111. It is divisible by 11 and I'll get 101. Okay, how? See, 11 ones are 11. Now next digit is 1. 1 doesn't come in the table of 11, so I'll put 0 here. Then I'll divide now these two numbers. That makes 11. So 11 ones are 11. Now 101 I have got. As I know it is a prime number and it can be divided by 1 or the number itself. So 101 will be divided by 101 only. And it divides 101 at 1. So here I have got the prime factorization of 9999. 3 multiply 11 multiply by 101. Now question number 5, write the smallest 5-digit number and express it in the form of its prime factors. Now again, smallest 5-digit number is 10,000, right? You have to find out the factors of prime factors. I should not say factors, I must say prime factors. So of 10,000. So 2, in the table of 2, where it goes, 2 5s are 10 and rest all the zeros will come as it is. Again divided by 2 you'll get 2500, again divided by 2 you'll get 1250, again divided by 2 625 you'll get. Then you'll divide 625 by which number? You have to remember the divisibility rules. As last digit is 5, this number will be divisible by 5, so divided by 5 we'll get 125. Then again divide by 5 we'll get 25, then by 5 we'll get 5, then by 5 we'll get 1. So this is the prime factorization of 10,000. That is 2 multiply 2 multiply 2 multiply 2, 5 multiply 5 multiply 5 multiply 5. And why this is called prime factorization? Because all the factors which we have got here, all are prime numbers. Yes, if you divide 10,000 by 10, if you divide 10,000 by 10, then it will be wrong, because 10 is not a prime number, and we have to find out prime factors of 10,000. Now question number 6 is, find all the prime factors of 1729 and arrange them in ascending order. Now state the relation, if any, between two consecutive prime factors. Look, now 1729. Now I know this number is divisible by 7. Okay, so I have divided this number by 7 and I'll get 247. Then I have divided this 247 by the number 13. I'll get 19. And I know 7 is a prime factor, 13 is a prime factor. Now 19 is left at the last. 19 itself is a prime number, so it will be divisible by only at its own table, that is 19. So 19 ones are 19. So now the prime factors of 1729 I have got as 7 multiplied by 13 multiplied by 19. Now what is the relationship? First of all, I have arranged these factors in ascending order. And now I can see the relationship clearly. If I take out the difference between the factors, that is 19 minus 13, I'll get 6. And 13 minus 7, I'll again get 6. So difference between two consecutive factors is 6. Thank you and have a nice day.